Hw2, we are finding the diameter of the graph. Regarding the graph analytics, it's like one of the challenging areas in the field, and there are many real life uses. Graph is like mainly used in transportation, navigation, and we like coming to roads and roads are like large networks. We can create an efficient schedules, and it's also been used by like Google Maps, with finding out the shortest route between any two given points. So in this assignment, like suppose we are given a large data set, we are using SQL queries, using recursion and joins to find the diameter. Like why we are using recursion and joins, in the sense like we are trying to optimize it as much as possible. And coming to diameter, in the graph, diameter is like the longest shortest path between any in all the vertices in the graph. So how we implemented, in the sense like firstly we are using the Vertica Python, which is like a Python library, um, and then we're gonna connect it to the database. Here we have like the four input arguments, which I'll show you like while running. The first argument will be the table. The second argument will be like the source, and the third argument will be the destination, and the final argument is like the recursive depth. And then coming to the queries itself, so first the recursive query. Here what we are doing, in the sense like we're gonna initialize an expression r, with values like one, source and destination, columns from the graph, which are like taken as input. We are initializing the d with 1 initially, because so that we can get the pairs of source and destination with values 1. And then we're gonna, here you can see, uh, we are doing union operation, and then we're gonna increase the d with 1, and we're gonna take the source of r and destination of e. So we like how and I mean it will be done uh, when the destination pairs of sorry, when the source of e and the destination of r matches. And then as you can see, we are performing the union operation, and the d is obtained through this query with the values are like already existed in the r. This is kind of like a recursive step, and it will happen until the d is less than k. And like here k is like the recursive depth, which is all which here you can see, which we pass as an input. This one, after that we will create a shortest path table, where we store the shortest path between existing vertex paths by selecting like the minimum diameter among all the diameters present between the vertex pairs. And after that we are grouping it by source and destination of r. We also got like suppose if the short firstly we're gonna drop a shortest path table if in case it's already exists. After that we got like the shortest path between all the possible pairs, and then we need the diameter. Finding the diameter is like just finding the maximum of max of d in the shortest path table. So I'm gonna, after that, like finally we're gonna print the shortest path, like the diameter, along with the table containing the shortest paths. Finally we're gonna close the db. I'll show you like how to run this is the command we are using. Here you can see the task is diameter. These are the arguments which we are passing. The first one is the table, which is diameter test. Source is I, destination is j, and k is the recursive depth. You can see the diameter of the graph diameter test is 4. The shortest paths between all the vertices are stored in like this is the table name. Regarding the contributions, the queries has been written collectively by the whole team. The Python integration is done by Nagalakshmi and Karan, and the report has been done by myself, Nitin, and Nikhil. Thank you.